Hello, everyone. You are welcome to today's lesson. And today's lesson is going to be lesson 5, okay, on functions. Okay, the topic was functions. We are going to continue from where we left off in lesson 4. If you remember, in lesson 4, we looked at how to find the value or values of x for which a relation or a function is undefined or not defined. And we looked at a situation where we had our relation or a function not given as a single fraction, but rather as partial fraction. And I took you through how to deal with, okay, those situations. However, today we are going to look at another special situation, okay, and it is not difficult. This time around, we'll be looking at finding the value or values of x for which a relation or function is 0. Okay, we know the value or values, okay, of x that will make the function undefined or not defined. But we've not learned, okay, that of what the 0 situation. That's the function or the relation will give us what 0, that situation. And that's what we are going to look at. Okay, so the last aspect of functions, concept of functions that you need to know is what we are going to do today. Okay, so quickly, let me take you through this. After that, if you have issues, then I will throw, okay, more light on what we have here, okay, to bring you on board. The possible value or values of S, where a relation or a function, and here I'm using a general function, f of x, equals 0, are called the roots or zeros or x-intercept. So it means these three words can be used interchangeably of the relation or function. So if you are asked to find the 0, it's the same as you being asked to find, okay, the roots or the x-intercept of that word function or that relation. Okay, and these are the steps that you are supposed to go through to get what the relation or function it was zeros. Okay, so to find all possible values of s for which a function f of x is 0, okay, step 1, we equate the function to 0, i.e., if the function is f of x, remember we said the function that we are looking at here is f of x, you equate it to 0. So you set your function to 0, okay, the whole of your function to 0. Then after that, what do? Okay, step 2, you solve the resultant equation. So again, your resultant equation could be linear, it could be quadratic, it could be what, cubic. And when we're looking at the undefined and not defined situation, we encountered these kind of what equations. So when we get there, we just have to employ, okay, our skills that we've acquired so far in solving those kind of what equations. Okay, so if you remember when we're looking at the undefined, for undefined, we said that it is the denominator function that, okay, we set to 0 and we solve. However, for the zeros, we don't set the denominator, but we set the whole of the function to 0 and we solve. Just because, from the concept of the undefined, okay, we said if I have maybe A, okay, over B, okay, this will be undefined when my denominator B is equal to 0. So that's the main reason why if you are looking for the undefined, you set the denominator to 0 and you solve. However, if I have any fraction, A over B, okay, under what circumstance would this fraction be 0? Any ideas? If I have a fraction A over B, under what situation, what circumstance would the fraction be 0? Any ideas? Okay, Prof. Elizabeth.
Please, if A is equal to 0.
Very good. When your numerator is 0, as simple as that. So here, what do? It will be your A that is equal to 0. So you setting the A being equal to 0 or to 0 is the same as you setting the whole of the function. So if the function is A over B and you equate it to 0, what if you cross multiply, won't you get A is equal to 0? You get it?
Yes.
Okay, so here the basic concept that you need to know, or the idea, is that you set the function to 0. And once you set the function to 0, then you are no longer looking at what? An expression or a function, but you are looking at an equation. So you go and solve, okay, that resultant equation. That's all. So we are not going to do anything special. We'll be solving equations. That's all. All right. So quickly, let's look at the first, okay, set of examples. So where the example 1, find the value of values of x for which the following relations or functions are, okay, 0. So you have about, I think, 5 functions. Obviously, the one in red, okay, will be for you. And it's likely to be a class exercise. So we'll be looking at A up towards D together, probably. Okay, so quickly, let's go and look at what's the solution. Remember, I've told you, anytime you read question, make it a point to underline the salient part. So here we are supposed to find, okay, the value of values of for which the following functions, okay, will be 0. So you are interested in the zeros. So indirectly, the question is asking us to find the zeros or the roots or the x-intercepts, okay, of the functions or the relations. So now, after underlining the salient parts, the first thing that you write is solution. So anytime you are presenting your solution to any assignment, please, I need to see solution in your presentation. Even if you won't write it in full, you know the short form. Though I will encourage you to write it in full because you've never seen me writing solution in the short form. Maybe S, O, L, then N, then you underline. It's better that's not universally accepted. Write it in full. Okay, take notes. All right. So now, remember, if questions are numbered, you need to number your solutions as well. So here, there is a major question number here, which is question number 1. So you write that one after the solution. Okay, after that, what do we have? Can you extract any information, okay, attached to the one? No. The vital information is what you have underlined. You won't extract. Okay, so you come towards the A. So you come and write A. Okay, so it means now you are giving out the solution to question 1A. So is that you can extract. So remember, we start with giving whenever we are extracting. So that will give us what? F of x, okay, is equal to what? 2x plus 1. Now you know, okay, just like when you are looking at or you are looking for the undefined or the not defined, okay, you start your presentation with something. You write for undefined, for not defined. Okay, but here we are looking for the zeros. So you write for the zeros. Be very careful. You start with it. So for the zeros, so that we can really, and the zeros, please take note, there is no E. There is no E. So for the zeros, okay, your function f of x must be set to 0. So that will be equal to 0. As you mature, you won't do this. So this is the first example. So I will take my time. As you mature, I will tell you the steps that you can take out. So this implies that, okay, you can see I'm using implication because what I am dealing with here is now an equation. So I cannot use equal to. At this point, we should all know when to use the implication sign and when not to, or when to use the equal to and when not to. Okay, take notes. All right, so now what is f of x? F of x is what? 2x plus 1 is equal to 0. Okay, so at this point, what equation are we dealing with here? A linear equation. And we are all experts in solving linear equation. So you go and solve for x. So 2x will be equal to minus 1. Okay, can I divide straight away by 2? My professors, can I divide this one by 2? You know, I told you what are you supposed to do?
Rewrite.
Yeah, you write it again, especially when the equation has a monomial on each side of the equal to. You have to write it again. You can't do it mentally. So you write it again before you divide. Take note of this. Some of you, okay, you are not adapting, okay, the way I want you to adapt. So I will continue to hammer on that, okay, repeat that just to emphasize for you to do the right thing. So at this point, we end up getting x to be equal to, okay, minus 1 on what? On 2. So you draw your conclusion, therefore, x is equal to minus 1 on 2. You are done. Don't go and write, therefore, the zeros are, or the 0 is no. Okay, just write, okay, just conclude with the x value. Just as we concluded with the x values when we were looking at the undefined and the not defined situation. Take note. Is my point well made here?
Yes, please.
Okay, so I guess you are all following. Well done. Okay, so now let's move on to B. Okay, and remember, I've never left any, okay, lines between my steps here. Every line must be occupied. Immediately you start. The only space that I've left here is when I'm moving from a sub question to another sub question. Otherwise, you don't leave any space or spaces between your steps. Okay, so now at this point, we go and extract. Okay, so what are we giving? Okay, J of X, okay, to be equal to 4 minus 3x. Okay, so this time around, I will handle this one maturely. So I'll write for the zeros. As for that one, you have to write it always. Okay, if you straight away come and write f of x is equal to 0, it doesn't carry any meaning. There is a missing, okay, link there. But if you write for the zeros, f of x, then we know exactly what you are doing. So this is very, very important. Okay, so for the zeros, okay, then here, we know that your function must be equal to 0. So here, what is our function? Instead of writing g of x is equal to 0, you know g of x. So straight away, okay, pick the g of x, which is 4 minus 3x here, then set it to 0. So you can see that this step, okay, what I have here, you can take it out because it's the same as this. Is my point well made?
Yes, please.
Okay, very good. Okay, so now, again, you are confronted with what? A linear equation, so you go and solve. So it's an equation. So my next step, I write close to the margin. You can see that anytime you are moving, okay, to the next line, write close to the margin. Whatever you would have written here, okay, if you didn't want to write close to the margin, that's what you write close to the margin. So here, I know I will write implication or I can ignore the implication, but I cannot use equal to because now I'm dealing with an equation. Okay, so take note. And I cannot write equal to also here. Please take note. You can't write it. When you are writing, sometimes read and see whether what you've written makes sense. If I come and write equal to for the zeros, you can see it doesn't really make that sense. Okay, so now here, what do we have? You have 4, then you move this 3x to the side. Okay, to make it positive, you are solving for x. So I will write it this way. It's equal to 3x. A term here, a term here. So I cannot divide straight away. I need to write it again. By writing it again, I'll write my 3x here. That doesn't mean I have moved, okay, the 3x to the side. If A is equal to B, then B is equal to A. That's the concept that I'm using. Or you can still maintain your x term here, then, okay, I mean, write 4 is equal to 3x, then divide. If this will confuse you, take note. Over 3, then over 3. So at this point, if I move on, I am going to get x to be equal to what? 4 on what? On 3. Because this 3, okay, will cancel the 3 here. Now, you know you are going to draw your conclusion. Can I say that therefore x is equal to 4 on 3? Can I draw my conclusion that way?
No.
Okay, all right. In actual fact, you can, but you shouldn't. Okay, it will come with a cost. Okay, so take note. We have to change it to what? The corresponding mixed number. So it will be one whole number, 1 out of what? Out of 3. So always avoid concluding with an improper fraction unless otherwise stated. Take notes. Okay, any questions at this point? We are all fine, Abby?
Yes, please.
Okay, and those of you, okay, who have adapted in terms of the way solutions are presented, I believe now when you take your presentation, looking at where you came from, you take your presentation, it's very appealing to you. Is that not it? And you
Yes,
can
please.
really relate. So try and adjust. All that I'm saying is for our own good. Not that I expect too much from you. Okay, you are professors anyway, so if I expect too much from you, that's not, okay, a big deal. But the point is, try and adjust. All that I'm doing is for your own good, to protect our mark. Anybody that takes your presentation will be very okay with it. And once I have that effect, okay, sometimes, okay, we can give you some mark. Though, number one rule when we are marking, no marks for sympathy. Okay, by your presentation alone, okay, can attract us to give you something sometimes. Okay. All right. Oh, really? Okay, so Prof. Leonard, disconnect and reconnect and let's see whether the problem will be solved. Okay. All right. So now let's see. We are going to move on to that of what? Of the C. So C, or let me even move on to the next page if I have. I think I have. Okay, so C. Okay, what are we giving? Okay, giving y is equal to, so this time right, it's a relation, but every relation is a function anyway. And every function is a relation, I should say. Okay, every function is a relation. Okay, not all relations are functions. Okay, take note. Okay, so here, this is a relation, but obviously a quadratic relation. So you should know if you equate it to 0, you are going to get a quadratic equation. So at this point, we write for the zeros. Okay, comma, you set your function y to 0. Okay, so in this case, okay, s squared minus 2x minus 3 should be equal to 0. So you are dealing with a quadratic equation. Once it's an equation, my next step, I use implication or I can ignore, but not equal to. So here, thankfully, our leading coefficient is 1. So it means you have to, okay, check, okay, the factors of your constant here, the C minus 3. That's when you multiply, you get minus 3. When you add, you get minus 2. Okay, so Lola Brown, I don't really get your question. So if your audio is working perfectly, please put up your hand, okay, and come better. Okay, all right. Okay, so Prof. Bishop. Come again. Okay, so we will use 3 and what? And 1. Are you sure it's positive 3? So say it well. I don't know whether I didn't get you well.
Please, I said negative and positive 1.
Okay, negative, okay, 3 and positive 1. Very good. So that will be the factor pair. Okay, Prof. Lola Brown. Okay, so please come clear.
Sir, please, good morning.
Good morning.
Please, I just came in. I was asking, like, if you're solving for the zeros, is this how you write it?
Okay, so yes, for the zeros, you just set the function to 0 and you saw.
No, sir, like the way I've written the zeros.
This one?
Yeah.
Okay, so you want to be, you were thinking it should be what?
I thought like you write like Z, the normal zeros.
The normal zeros, as in ES.
As in ZE.
ZE. Yeah, this one is Z. I won't mind. You want to tell me that my handwriting? This one is Z. That's how I write my Z. Okay. Okay, I do get you now. Okay, so no, you going forward, I'll write
Thank
it.
you.
I will write it the way you write your Z. Okay, I usually write my Z this way. Okay, though it's not appropriate, but
Thank
I'll write it
you.
this way going forward. Okay, thanks for drawing my attention to that. Okay, handwriting equally matters when you are teaching. Okay, and in math, whatever you write is very important. Sometimes this can represent, okay, a certain symbol in mathematics, so you can change the meaning. So going forward, okay, thanks for drawing my attention. I will do that. Okay. But apart from that, I think my handwriting is legible.
Yes, please.
Okay, good. All right. Okay, so now we can continue. Okay, though I'm using a digital board, but I think my handwriting is not that bad. Okay. Okay, so now what do we have? We have gone for the pair, and we said it will be minus 3, positive 1. So we split this one using, okay, the pair. So s squared, then minus what? 3x. Okay, then plus what? 1s, but you don't write the 1, so it will be x. Then minus 3 is equal to 0. Once you get your pair, you have no business getting it wrong, unless the advice that I gave you in terms of the grouping, you decide not to take it. Okay, in that case, you can get your pair correct or your pairs correct, but you won't get the full score. So remember, you factorize by grouping, first two and last two. But I've told you, never, okay, never in bold, okay, and in capital letters, underline as well. Okay, please never use the bracket to group. It can be costly, as some of you saw in your, okay, the assignment. So group the first two, then factorize. First two, if I'm factorizing, do I have any number apart from one that I can bring out? No. Do I have any variable? Yes, x is common to the two. So x out, and I'll be left with x minus what, 3. Okay, then plus any number apart from one that I can bring out? No. So I'll write 1 into, you can choose even not to write the 1, simply understood to be there though. Then x minus what, 3 is equal to 0. Is my point well made?
Yes, please.
Okay, so now we are going to get the complete factorization, s plus 1. Okay, then x minus 3 equal to 0. And take note, you can see that at this point, when you set it to 0, at this point, you'll be solving or be dealing with equation. So all throughout, you have to see your equal to line. Something is equal to 0 all throughout. Other than that, if you ignore the 0 here, then you move from an equation to an expression, which will be wrong. Take note of that. Wow, Leonard is still having that issue. Okay. I'm coming. I will see how best I can help you resolve that. So going forward, so now we are going to get x. You set each of the factors to 0. S plus 1 is equal to 0. And remember the connector, or you can't use comma, you can't use and. X minus 3 is equal to 0. So x will be equal to minus 1 here. X will be equal to what? 3 here. Okay, so now you draw your conclusion. Therefore, x is equal to minus 1 or 3. So meaning if s is equal to minus 1, your function will be 0, which in this case is y will be 0. If s is equal to 3, okay, y will also be 0. If you like, we can investigate. Okay, and later you can go and do the investigation for a and b, the values that we had. So this will give us negative 1 squared. So if you just investigate, it's not necessary. If you do the right thing, it's not necessary for you to investigate. Okay, so minus 1 squared minus 2 into what? Into minus 1. Okay, then minus 3. Let's see if that will give us 0. So this will give us minus 1 squared is 1. Okay, then this will give us what? Plus 2. Then minus 3, obviously 0. So indeed what we have here. So if you come and investigate that of the 3, 2, you end up getting 0. So indeed, these are the s values that will make the function, in this case, the relation 0. All correct.
Yes, please.
Great. Okay, so the last one. Okay, then we move on to our next set of questions. So now we look at D. Okay, so when you are moving from C to D, you leave a line, maximum 2 lines. I said 1 line will do. So given this time round, it is h of x is equal to, and it's 3s squared, okay, minus 8x, okay, then minus 3. Okay, so at this point, we know for the zeros, okay, so I'm careful here, all right. Okay, so I've written the normal z. Okay, for the zeros, okay, your function h of x should be equal to 0. And your function h of x is 3s squared minus 8x, okay, minus 3 should be equal to 0. So now we moved from a relation or a function to an equation. So you ask yourself, what type of equation am I confronted with? And obviously, it is a quadratic equation. So you have to employ your skills in solving quadratic equations here. So let's see if this is factorable. Okay, then we will use the method of factorization. So 3 times minus 3, and that will give us minus 9. So we need to go and look for the factor pair of minus 9. That's when you multiply, you get minus 9. And when you add, you get minus 8. So which factor pair? Which factor pair?
1 and -9.
Negative 9 and positive 1.
Okay, okay, so it will be minus 9x, then plus x, okay, minus 3 is equal to 0. Okay, so at this point, we are in a comfortable lead. Take the first two, group mentally. Okay, don't use the bracket to group mentally and factorize. Take the last two and group, okay, mentally and factorize. So first two, okay, if I'm factorizing, the first question, do I have a common numerical factor that I can bring out? And the answer is a big yes, which is 3. Do I have a common variable factor that I can bring out? The answer again is yes, okay, x. So it means I can bring 3x out. Okay, so if I bring 3x out, because I'm dealing with two terms, the bracket here will have two terms in it. And each of the terms, how do I get it? By dividing the term here, okay, the original term by the quantity that I took out. So 3s squared over 3s will give me x. Okay, then minus, okay, the same 9s divided by 3s, and that will give us what? 3. Okay, then you come and do same for the last two, group and factorize. 1 out, then you get x minus what? 3 is equal to 0. Don't forget. Okay, so at this point, I have 3x plus 1, okay, into x minus 3 is equal to 0. So I have what? Set each of the factors to 0 at this point. Or the connector is very key. X minus 3 is equal to 0. Solve below, but I can see that this one needs little or no work. Okay, so I will move 3. Then come and, okay, stress myself here. So 3x, okay, is equal to -1. Write it again before you divide over 3 over 3. So you get x to be equal to -1 on 3. Okay, then at this point, you draw your conclusion. Therefore, x is equal to -1 on 3 or 3. All correct. Hello?
Yes,
Are we all
please.
fine, my professors? Are you there?
Yes, please. Yes.
Great. Okay, you are doing well.
Yes.
Okay, we are done with the
Yes.
first set of questions. Any questions before we move on to the question 2? Any questions at this point? Okay, so you are fine. We thank God. Okay, so we'll move on to the next, okay, set of questions. So this time around, unlike the first set of questions where we had, okay, polynomials, meaning, okay, we didn't get any denominator, any fraction here. The functions or the relation that you can see, we are dealing with rational relations or rational functions. Okay, you have a denominator, okay, a quantity over another quantity. So take note, how do we deal with such, okay, situation? And that is going to be, okay, our next, okay, task. Okay, you will get it, don't worry, it's not difficult. Indirectly, I've given you the hint in the introduction. So quickly, let's go and have a look at what's the solution. Okay, so as usual, when you read a question, okay, you underline the salient part. What are we supposed to find? The zeros. Okay, of the following relations or functions. So questions are numbered because we want your solution to be numbered. If it's not numbered, then don't number your solution. So in this case, I write solution is what I write first, then I come to question 2. Okay, then do I have any major information that I can extract here? No. So I come down. So A, I have an information that I'm supposed to extract or pick. So I write given, and please take note, your gene that you have there is a capital G, not a small g. Okay, you know yourself. Okay, I almost forgot. Okay, please take notes. Anytime you are starting a statement, okay, it should always be a capital letter. Take notes. Okay, so now what do we have? It is f of x, okay, which is equal to, it came in the relation form, you thank God. So you extract it in that same form, x minus 1. Okay, so this is your first function. So again, we are going to write for the zeros. Hey, I've written, because usually that's how I write my z. Okay, so I consciously have to adapt. Okay, so that is nature. It will sometimes take some time before you adjust, but I'll consciously do so, as I did in the previous one. So now for the zeros, okay, I should have written D. Okay. the fact that, okay, this is mass doesn't mean you should write anything. What you write there should also contain, okay, the perfect English. So for the zeros, I almost write it my usual way. Okay, so comma, you are supposed to set your function to 0. So it means x plus 1 over x minus 1 is equal to 0. Is that clear? Hello, is my point well made?
Yes, please.
Okay, very soon we'll handle it maturely. Remember, this is the first example. Okay, so now this now is an equation, so you start with implication or you can ignore. So if you are solving this, you know what do? We cross multiply. So it will be whatever you have here times 1, then whatever you have here times 0. So it means in effect, we are going to get x plus 1 is equal to 0. All correct? So if you solve, we are going to get x to be equal to -1. So therefore, x is equal to -1. So meaning if x is equal to -1, the function here will be 0. And let's see, if x is equal to -1, I'm going to get -1 plus 1, which will give my numerator to be 0, over, once my numerator is 0, irrespective of the value that I have in my denominator, the result will be 0. Afar, is my point well made?
Yes, please.
Because you get 0 over -2, and 0 over -2 is what? Is 0. So indeed, x is equal to -1 is one of the zeros, or in fact, is the zeros. So now we move on to B, if you are all fine. Oh, sorry. Okay. So B. Okay, so B, what are we giving? We've been giving g of x to be equal to, what do we have? 3x minus 5 all over. Very soon, okay, your work will come and you'll be occupied. So 2x plus 1, okay, into what? X minus 3. Okay, so this is what we have. So this time around, I'm going to handle it maturely. So you start by writing after extraction for the zeros. So consciously, I'll write my z's this way. Okay, so comma. Okay, so for the zeros, the whole of the function ordinary should be equal to 0. But you said, remember in my introduction, I asked you if I have a over b, under what circumstance will a over b give me 0? And you said the numerator, which is the a, should be 0. So here, just come and set the numerator to 0. So for undefined, it is the denominator that we set to 0. For zeros, it is the numerator that we set to 0, period. Is my point well made?
Yes, please.
Great.
Yes,
So
please.
now we are
Yes,
going to
please.
have 3x minus
Yes,
5 is equal to 0. What type of equation are we confronted with here? Linear, quadratic, cubic. Which equation? After setting
Linear
this
equation.
linear equation. So linear equation, our usual, okay, equation. So once it's an equation, the next step, implication. So I write 3x is equal to, move the -5 to the side, which will give me 5. Okay. So now at this point, you write it again before you divide. Don't forget. Very important. Over, okay, 3. So now, what are we going to get? We are going to get x to be equal to what? 5 on 3. Okay, so I'm going to conclude, therefore, x is equal to 5 on 3. Am I right?
Yes,
Yes,
please.
Yes,
Hey,
please.
if you
That's
said
just into
yes, if you
no,
It's
said
supposed to
no.
change
yes,
Proper fraction.
you
A
will
mixed
put
fraction.
in
No,
the
you have
work.
to change it to a mixed fraction.
Very good. You see, learn to protect our marks. Please learn to protect our marks. So I will go up here and do the right thing. So therefore, okay, x is equal to, you change it to the corresponding, because this fraction here is an improper. And remember, we don't conclude with an improper fraction unless otherwise stated. So we will change that to its corresponding mixed number. So that will give us what? One whole number, 2 out of 3. All correct.
yes, please.
Very good. Take note of that, please. Okay, the way some of you didn't take it easy on me, though I did it intentionally. So you should know, when you also don't do the right thing, I won't take it easy on you. Okay, so this is what we are supposed to get in terms of what the solutions, okay, for A and what and B. Okay, 2 more to go, then your classwork will come. Okay, the target, I'm well within target. Okay, the target is to use the first hour to at least do this. Okay, so now C. Okay, what are we giving? You extract what we are giving. And what are we giving? Okay, h of x is equal to 3x squared, okay, plus 7x all over, okay, x minus 4 all squared. Okay, so at this point, you know, for the zeros, comma, if you have space, you continue. I don't have space, so that's why I'm coming down. Okay, so my numerator function, which is 3x squared, okay, plus 7x should be equal to 0. So instead of equating the whole of that to 0, then go and cross multiply to end up getting this. Okay, remember we are now mature. We know that is the numerator that we should set to 0, okay, for us to get the zeros. So obviously a quadratic, okay, equation at this point. So once you have a quadratic equation, you know what to do. If you can factorize the quadratic expression, you do. Okay, then you use the method of otherwise you use the other two, any of them. So in this case, there is no common variable, sorry, number that I can bring out apart from 1. But I have a common variable, which is x. So I can bring s out. If I bring s out, I'm going to get 3x here, then plus 7. Do you agree?
Yes, please.
Okay,
Yes,
very good. You cannot divide through by x. X is a variable. Remember, for equations, you can only divide through by a constant or multiply through by a constant. You avoid dividing through by a variable. By so doing, you might discard a possible solution. So you can see that if you divide through by x, you end up getting 3x plus 7, okay, which will give you the solution for only this one. This solution, which is the s solution equal to 0, will be discarded by dividing by the variable. So we always don't advise, okay, I mean, we always don't allow, or we advise you don't divide equations by a variable. Even expressions, you don't. For expressions, remember I said you cannot divide by neither, what do you call it, a constant nor a variable. But for equations and inequalities, you can divide by a constant, but not a variable. Take note. Okay, so here, product of two factors giving you 0. So your first factor, variable factor, should be equal to 0, or your second variable factor, which is s plus 7, 3s plus 7, sorry, should be equal to 0. So at this point, this x is solved for. You come and solve for x here. So I'll get 3s is equal to minus 7. I write it again before I divide. Okay, minus 7 over 3 over 3. So I will get x to be equal to minus 7 on 3 here. Even this particular step here, you can ignore. Okay, this step you can ignore, don't worry. So now, therefore, you get your x to be equal to 0 here, or x is equal to, help me. Please, I need help. X will be equal to what?
Negative
Whole number
number
1 on 3.
Okay, so negative 2 whole number 1 out of 3. Remember, this is an improper fraction, so you change to mixed, okay, numbers. Okay, thank you, okay, for the solution to that of what? Of the C. So quickly, let's do the last one together, the D. So let's move on to, okay, the next page. So D. Okay, before we look at D, any questions, please? If you have issues, don't hide it. I always tell you I'm here because of you. Okay, so ask. Okay, even if I'll pull your legs more, don't worry. Okay, ask. Okay, so giving x cubed, okay, plus x squared all over, okay, your s squared minus 4. Okay, so here for the zeros. So you can see that consciously within this short time, I have adapted to okay, write a Z, okay, though almost throughout my whole life, I've been using that Z. With this short time, I have consciously adapted, okay, to use it. So you can also do same. Okay, so for the zeros, comma, okay, your numerator, which is S cube, oops, okay, so S cube, okay, plus what? S squared should be equal to 0. All correct? So now,
Yes.
this implies that, okay, here can we, this is a cubic what? Equation, because the highest power is 3 of the variable. So we've gone beyond the quadratic. So we are now looking at cubic. It's the same thing, whether it is cubic, quadratic. The first technique of solving, provided your expression here, your quadratic expression, your cubic expression is factorable. Factorize, use the method of factorization. So obviously this is factorable because the number that I can bring out, okay, no numerical coefficient, factor apart from 1. So it's 1, you don't write it. But there is a variable factor, which is S squared. And it's X, but you bring out the one with the least power, so X squared. Okay, then you will be left with X, okay, plus 1. Do you agree? It's equal to 0. My professors, are you with me?
Yes, sir.
Yes.
Okay.
Yes,
It's,
please.
who
Yes,
wants me to
sir.
come again? Today I have not asked this question. It was
Sir,
intentional
please
though.
come again.
Ah,
Thinking.
all right. Okay, so you know when you are factorizing this, okay, so X, okay, plus, let me say S squared plus X. Anytime you are factorizing a variable, okay, you write the variable, but look at the terms. The variable with the least power is what you can bring out. So here the power is 1. So it means you brought the power 1 out. But if you want to get the terms in brackets, okay, which because you are factorized, immediately you bring your common factor out, bracket comes. If you want to get your terms in bracket, take each of the terms and divide by, okay, what you took out or you brought out. So you get S squared over X, and that will give you S. So that becomes the first term here. Then plus this will give you X over X, okay, and that will give you 1. So in the same way, that's what I did here. Here, okay, I can see that it's S cubed plus S squared. I don't have any numerical factor that I can bring out apart from 1. So there is no constant that I can bring out. But the variable I do, this contains X, this contains X. Okay, so each term contains X, so it means I can bring out X. But, okay, the X should come with a power because I can see S squared, S cubed. Which power do I bring out? Remember I said you bring out, okay, the X with the least power. And the least power here is 2, so it means you bring out the S squared. Okay, and you come and do exactly what I did here to get the terms in bracket. Because you have 2 terms here, you should have 2 terms in bracket. So how do I get the first term in bracket? By taking the first term, okay, here, then dividing by your S squared, what you factorize. So that will give you X. Then for you to get the second term, take this one, then divide by the quantity that you brought out. So S squared over S squared will give you 1. Is it clear now? Okay, so maybe you will not be this time lucky. I won't
Yes,
ask
please.
who wants me to come again. So if you don't get it, let me know. All right. So what are we going to get here? You set each of the factor to 0. The first variable factor is S squared. That should be equal to 0. Or your second variable factor, S plus 1, should be equal to 0. So now let me come and solve for this. X is equal to, okay, -1 here. With this one, it's the same thing. Okay, you know, anytime you are solving for X, remember X has a square, so you have to take the square root. And I told you, anytime you are taking the square root, what questions do you have to ask yourself? Okay, I want someone to make me proud. Anytime you are taking the square root, what did I say you should ask yourself before, okay, taking
You
the
must
square root?
consider if the number is positive or negative.
Okay, the quantity that you are looking for, if you have sufficient information to say that it's really positive or it's really negative. Thank you very much. So here we are solving an equation, okay, which will be the S value. And S value can be positive or negative anytime you are solving an equation, or even 0. So in this case, okay, it means we are supposed to introduce plus or minus here. then we take the square root. But unfortunately, we don't have plus or minus 0. So to show our maturity, 0 is a special number. So any other number would have written plus or minus, but the 0 will write a plus or minus there. Is my point well made?
Yes.
So take note. I always say, tell my students, okay, the young will know the rules. Okay, by the elderly and the wise, they will know the exceptions. So take note of that. Okay, so now this will give us x is equal to what? 0. Okay, if you wrote plus or minus here, you still end up getting, okay, because you won't say that x is equal to minus 0 or 0. Obviously, we don't have minus 0, so take note. So at this point, you come and draw your conclusion. Therefore, x is equal to what? 0 or negative 1. Afa?
Yes, please.
Okay, so we are all fine. Okay, so on that note, okay, that brings us to the end of what the concept that we are supposed to learn today. So the next, okay, this becomes your class assignment. You will do it, you send it, then we'll come back to class and mark together. Then after that, we'll go and look at likely exams questions or okay, past what questions, the nature that you see past questions. Okay, so this becomes, I'll capture it and put it on the platform very soon. But let me go back. Maybe some of you still want to write. Okay, so this brings us to the end, okay, of this particular concept and the end of what this first session of today's word class. Okay, so if, all right, any questions? Okay, Prof. Nana Kwame.
Sir, please, can you go back to question C? I want to copy something.
Okay, you better capture, don't copy, okay, to save time.
Okay, sir, I'll cut to calculate.
Okay, all right. Okay, all right, so if that is the case, then I will bring the curtains down here. God bless us all.